Hey everybody, Lars here. Live and in person. Well, not live, recorded, but this is the summer of 2021. It's a contemporary video. I just wanted to do a couple of things. One, check in and say hi. Everybody is doing great. Thank you very much for getting the midterms in the way you guys did. And it's knock wood, this class is running very smoothly, very few problems. This is a good cohort. The answers to the discussion questions are good, and everything is moving along swimmingly. The second thing that I want to do with this time, and hopefully I don't want to go long, it's 9:15 Friday night, but I do want to present this stuff to you because I always tell myself I'm going to do it with my classes and I never do. And this semester I'm going to do it because you're going to know why when I tell you the story. But last semester I had issues. The issues, and it's a touchy subject, but the issue is with academic integrity. Whenever I have had problems with cheating in this particular class, and don't get me started, cheating is rampant in computer science, especially at the undergrad level, and just Google it and read. You'll see that it's absolutely crazy. I teach the intro for undergraduate in the computer science department, and when we give tests, because of COVID, we've had to do it online. Within an hour, all of the answers to all of our tests are on Chegg, and students can just go look them up and get them for it's cheating is rampant right now. Frankly, unless you have somebody live and in person writing a program in front of you, you can never really be sure anymore, which is a shame in some sense. But usually this is grad school. Most people have that, do what it takes to get the job done properly, ethos, and everything is fine. But every now and again, you do get somebody who, in air quotes, cheats. At this level, and even at the undergrad level, I don't necessarily think, and, scholarly work backs me up a little on this, that it's malicious students twirling their mustaches and laughing like villains as they plan to cheat all along. It usually comes down to time, not being able to meet a deadline, getting nervous, wanting to get it done. So you ask your friend for some code, or you glom some code off somebody's laptop, or blah, blah, blah. That's usually what I think it comes down to, that it's like, I've got to do this report for this class, I've got to do this for this other class. Oh, yeah, by the way, I've got a family member sick, I got to visit them in the hospital, I got to do this, I got a flat tire, blah, blah, blah. And people take shortcuts. The thing is, when you're first starting out learning how to program, you don't know how easy it is. And it really is. After a year, you'll know how easy it is for somebody with just a little bit of experience to look at two pieces of code and know whether they're copied or not. So what I'm going to do, well, first of all, to keep telling the story, in this class, and I've been teaching this class since about 2015, whenever there has been an academic integrity cheating issue, it's always been in this unit because I like the assignment. You're going to see the assignments tonight. It's the deck of cards assignment, and I use it a lot. So solutions can get out there. Some people have put them on GitHub before, and I've asked them to remove them and other things like that. For all I know, you have a friend who's taken this class before, and they've given you some things. I implore you not to use it because of what I'm going to show you right now. The first thing I'm going to show you, and trust me, I was in everybody's shoes 30 years ago when I was an undergrad at St. John's University in computer science. I had my chances to cheat if I wanted to cheat, and I knew how to cheat. Number one, I was always scared to cheat. I didn't want to get caught. And number two, and this is what I always tell people, and I think I realized it at a young age, is that if you know enough to cheat well, if you know enough to cheat so that you don't get caught, well, then you know enough to do the damn assignment the right way from the beginning. So do the thing the right way from the beginning, because that's how easy it is for someone to detect cheating. And we're going to show that. The first thing I'm going to do, and this is a little black hat, so promise me you're not going to tell people about it, even though this video is on YouTube. I'm going to show you how to cheat. All right? So, first off, a little bit of villainy. Let's go grab some Python 9. And my name is Joey. Joey the Cheater. And I went out drinking tonight. Even though I had a Python program due, I went to the corner tavern and I got some $2 PBRs and I watched a few bands. And then on the way home, I stopped off and I had another beer. And I didn't get home till 1 o'clock. And my assignment is due in an hour. And I haven't worked on it. I haven't even thought of it. I'm in bad shape. And I even made a special. No, I want to go to Python 3.9. I have a cheater lab where I keep all my programs. Well, I made one for this called Video Cheater Lab because I had to anonymize a lot of stuff. I don't want you seeing any other students and other stuff I've worked on. There's Chucky's code right there. Chucky gave me his code. And we had to write a program that takes these numbers and adds 3 to them if I call a function called add3. And then sometimes I want to wrap it with a string literal in front of it and say the number is. So I do my 2 functions on the top. I then have a main program. I set up 3 variables, and I run tagit b. So 7 will be sent to tagit. The number is 7. Then I run tagit, but inside, in parentheses, I do add 3a. So I take 5, I do add 3, which just adds 3 to 5 and returns it. So that's an 8. And then I'll run tagit on 8. So it should say 8. And then I run tagit on c, which is 9. So it should say the number is 7, 8, 9. So we run this. And I say at 5, 7, 8, 9. All is good. So I've got Chucky's code. Chucky's code works. Now, if I'm a train wreck cheater, I come up here and I just say, hey, program a Joey. And that's it. And then that is identical. Well, first let me do this so I don't write over the original. Save as joey.py. And it was already there because I tested it. I'm going to say yes. So now this is my new Joey code. I could say programmer Joey and hand this in. I do that, I'm going to get bagged. So, what are some of the things that a programmer does if they want to glom somebody else's code and take credit for them themselves? Well, I'll leave that programmer Joey in there, but I'm going to lose that. And then maybe I can do my date here, get creative, and then I could just say Python class. And then I have def tagit and def add3. So the first thing we're going to do, the experience cheater will just change the order of the functions. Then instead of add3, I'm going to call it +3, but I'm going to spell the 3. And instead of tagit, I'll call it headit, like it's a header. So +3, head 3. What else can I change? I can change the variable, but I want to change it so it makes sense. I can just call it arg. Okay? And then I can do something like that. My number is, and then I can have main program. Frankly, I can lose that, or I can delimit with just lines. And then I've mixed up the order of my functions. I've changed the name of my functions. Now I'm going to rename my variables. I'm going to say num1 is 5. But I know a little secret about Python. I could do a semicolon, and that makes it look like a line is ended, but I don't have to go to the next line. So now I can say num2, 7, num3, 9, and do all that in one line. Okay? Now, when I get here, I'm going to put in a comment, and I'm going to say send b to +3 for a header. And then I'm going to make sure I give it the correct name, space, space again, send a to, actually I didn't, I just sent that. I want to send that to just head it. It's confusing being a cheater. Head it B. Send B to edit. For a header, this is the one that I want to send to +3 for +3 and then a header. Good enough. Government work. So now that's not tag it anymore. That's head it. And that's not add 3 anymore. That's +3. Even this little bit of cheating is a lot of work. Then I'm going to basically copy, come down there, V, send C to the header, and instead of tag it, I'm going to say edit, because that's what I call that. And then I'll even say print the end, just to do it that way. And then, like some people used to do in their programs, I'll just say end of program. You can add some fluff just to make it look different. Now, we're in Python, right? So indentation counts. If I'm in C or if I'm in Java, white space doesn't matter. I could be Jackson Pollock. I can put things all over God's creation. And that's yet another way to obfuscate. So, save. So now I run my Joey code. Of course, what did I forget? I got to put my new variable names in there. B was number 2. A is num 1. C is num 3. Her mileage may vary. What I do different this time? I said N, but I want to say arg. 7, 8, 9. So Joey runs exactly the same way as Chucky, but let's go bring Chucky back up. Now, let's get these side by side so we can look at them. All right, there's Chucky, and there's Joey. They don't look the same anymore, right? They look pretty different, even in my eye. And trust me, I've been doing this as long as Methuselah. And that doesn't look the same to me. That looks like it kind of gets by a little bit. Now, this simple program, granted, I'm doing this for an example. But if I'm a cheater, that's what I do. I take functions and I change their order, because that doesn't really matter. I'm calling them discretely. I change the comments around. If I'm been given code with a lot of comments, sometimes I delete them wholesale. If I've been given code without any comments, I comment it up. All of a sudden, I'm Charles Dickens, and I'm putting a bazillion words in there, right? Changing my variable names. If I'm a really experienced cheater, okay, I'm going to put a mistake in my program because I'm cheating. Maybe I'm okay with a B, all right? Maybe I don't want it to be perfect. Maybe I want a mistake. Maybe I hand it in, and that's num 4. So now I don't even look the same. Now I don't even work. But it's a small error. Maybe I'm getting a B. All right? It's a hell of a lot better than that F for turning in nothing, right? So there's different things you can think about when you are a cheater. All right? But there's a problem. If you plagiarize, right, and you use Turnitin or Sakai or something like that, you can have plagiarism detection software compare text, all right? If any of you were familiar with the operating system Linux, there's a small function command you can use called diff. And what it does is you give it 2 text files, and it tells you the difference between the files. And if you're doing plagiarism detection, you can go run a diff and see if I glommed something from Jack London, or if somebody wrote something in a published paper a year ago and I took a whole paragraph and did it. That can be detected using just comparison from document to document. Well, obviously in the case right here, I cheated. I took somebody else's code and I doctored it up in what I, as a level 1 cheater think is a clever way. And if you did a diff on this, you'd get quite a few differences. I've changed where my functions are. I've renamed my variables. I've done a whole bunch of different stuff. So us programmers, being clever people, came up with software similarity software. The most popular being something called MOS. Berkeley? No, Stanford. It's right there in the URL. Stanford hosts MOS. You can run a MOS server. We run one in the computer science department at Rutgers. And you can submit the code to MOS, and MOS will check it with what's on the internet. Okay, so you can look at what's on Stack Overflow and GitHub and all that. Or you can compare it to code that you're given and say, I've been given this code. Let me compare it to this and see if there are any differences. Okay? And the good thing about software similarity software is that it takes into account changing where functions are, renaming variables. It ignores white space. It's invariant when it comes to all of the things that the rudimentary cheater would do. So what you end up doing, and I'm going to show you how we do things with the Python course and how I do things in the computer science department. MOS is great. Don't get me wrong on MOS. I really like MOS, but I'm a Python guy. So I happen to know that if you're a Python person, there's a program called Picode Similar, I think it is, which is basically MOS for Python. And I have it here on my machine. So what I'm going to do for my Windows machine is I'm going to type CMD, and I'm going to get a command line. And now I'm going to use my old school 80s DOS knowledge to do a CD root and then a dir w, and that shows me all my directories. I want to go to Python 3.9, where I have my 3.9. Excuse me? Oh, I did something in front of it. And now I want to go to video. I'm hitting the tab. I don't type that fast. I wish I did. I'm hitting the tab to complete it. Video Cheater Lab, and I'm doing a -D. And I see Joey, and I see Chucky, and I see Piecode Similar is my code right there. So what you do, if you want to compare two pieces of code, is you would type Piecode Similar, and then the two programs. Now, if you have two disparate things, you're going to get a percentage underneath 50%. What I always test it with, and you know I'm a gaming guy, so I have a copy of Wormy in here, and I have a copy of Flappy Bird in here. When I run Piecode Similar on Wormy and Flappy, which are two very different programs, okay, I get 30%. You can see the number there. So there's 30% the same. Okay, that's kind of low. The issue is when I give students programs and tell them what to do, there's going to be some inherent similarity there because you're doing the same tasks. If you've already looked at the assignment for Unit 5, you're going to see I actually tell you what to call the methods in that one. There's a spec that you're following. That's going to lead to even more similarity. So what you really want to do is get a baseline. So I do have the students there, but they're anonymized. So what I did was I had two students who had cheated. So I run Flappy Bird and I say two things that are completely disparate, 30%. But what if I run it against this particular assignment? So what I do is I can do that to get the Piecode Similar. I have a piece of code called standard. And what standard is my solution for Unit 5. Okay? And then I would run it against student 1. Was it std1? Pi? Yes. std1pi.text. And when I run it, I got 76%. And I said, okay, 76% is similar. Then I went and I ran it for another student who also was being, I don't know, accused is a tough word, but also was in for an academic integrity violation, but had nothing to do with student 1. So I checked that code against the standard, and I got 72. So I'm like, okay, my baseline here is mid-70s, somewhere around there. Then you could even go so far as to, just for S&G, do student 1 and student 4. Now, they weren't working together, okay? They weren't part of the same grouping. So when I did that, I got a 73. That makes sense. They're in the same, assignment. They have, some things are similar, but they weren't really working together. Well, then, and this happened in the fall, I ran the code, and after this unit is over, maybe I'll show you some of the code. Anonymized, of course. I don't want you to know who these students are. It's text, actually. Student 1 and student 2 were accused of working with each other. When you look at the code, off the top of your head, there are some similarities, but they're not exactly the same. But if you account for comments and different things along those lines, 100%. And usually you get 98s and 99s, 100%. When comments were taken out, variable names were taken out, when functions being rearranged were taken out, it was a 100% match. Now, one of these students were gaslighting me and saying, oh no, I worked on this myself. Oh no, I never cheated. Oh no. And then I presented them with this analysis. And after that, it was like, oh my God, I'm sorry, Professor. I didn't mean to do it. Then all of a sudden, it's telltale heart. Then all of a sudden, they were admitting everything. So, back to what we just did. Piecode Similar. I'm going to compare wormy.py to Chucky.py. That's pretty low. It should be pretty low. Chucky is a dumb thing with 2 functions, and wormy is actually a functioning worm game. So that's pretty low. One issue, and I figure I may run into it with this, but I don't know, with software similarity programs, is if you're super simple, it doesn't really have enough to work with, which is a problem if you're in the first month or the first 6 weeks of a course and you're doing simple for loops or a bubble sort or something, small, and you guys are already past that, so I can speak like this. Sometimes it doesn't work. But, and you sat through it with me, as we cheated together. We're now criminals together. Highcode Similar, Chucky.py, Joey.py. Yeah, they're the same code, but let's see. They don't look the same, right? Got different names for the functions. They're in a different order. You'd have to know what you're doing. I mean, this is so simplistic. I don't even know if this would set off my spider sense when it comes to a cheating situation. All right? Piecode Similar, Chucky versus Joey, 100%. And then Piecode Similar actually tells me, hey, dude, tag it is probably headed. And hey, add 3 is probably +3. So it'll even tell me where the invariant stuff is. Okay? So this software similarity analysis stuff takes the easy things out of the toolkit of the rudimentary cheater. You're done. Now, there are other ways that we can do, not with Python though, interestingly enough. There are certain, and you can all look this up, so I'm not, talking out of class, but there are ways to beat similarity things. Like if you're in a language like C or Java and you have types then you could change the type of your variable. Like if you have an integer, you can change it to a long. Or if you have a float, you can change it to a double. Or you could do things like that. And that will look different to a MOS or a Picode Similar. But these are the high-level things you have to have in mind to beat a software similarity analysis. If you're smart enough to do that, do the damn program the right way from Jump Street, and you'll be fine. There's no reason to do that. That's why, and this is, you've seen this now, and you'll get a flavor for what I'm talking about. If you know enough to get by this kind of software, then you know enough to do it right from Jump Street. So do it right from Jump Street. If you don't have to cheat, why would you ever cheat? It's ridiculous. It's like a millionaire robbing a bank. There's no reason, no right or reason. Well, robbing a bank might be fun, so I take that back. Maybe not a good reason. How's that? The very last thing I wanted to show you is that when, and do I have it? Python data science? No. Python 3.9, video cheater lab. Do I have the spread? I do. I call it the cheat grid. And you'll see when I get academic integrity violations, I do cheat grids, and I anonymize this. And what I'll do is I had 5 students. Students 3 through 5 were accused of working together, and students 1 and 2 were accused of working together. So when I ran student 1 versus student 1, it's 100% because it's the same code. Okay? When I ran student 2 versus student 1, it was 100%. They cheated. They were using the same exact code. Okay? Now you'll notice when I ran student 1 versus 3 through 5, mid-70s. So they had nothing to do with each other. But when I ran student 3, 4, and 5 against each other, look at this. Hundreds, a 94, 86. These students work together. Okay? Now, an interesting side note to student 1 and 2 in the spring is I thought some of the code they were using looked familiar. I found a cheating incident in the fall and compared them to that. They were 100% there. There were 2 students who cheated in the fall, used this code, and gave it to their friends. And their friends were dumb enough to use it. Okay? Just absolutely crazy. And here I have it against the standard. So you'll see this is all in the 70s. So if you ran in the 70s, you were probably good versus my standard code. But if you're 86, 94, you're in bad shape. If you're 100%, you're done. Because that means comments, function rearranging, and renaming variables. Those 3 things off the top, if it's 100% after that, you glom the code. There's no way around it. You glom the code. And when you show this kind of analysis to people, they give it up. We have people gaslighting us, saying they didn't cheat, when the other half of the equation has already admitted to it. Another student will say, yeah, I gave Joey the code. I gave Joey my code. Or, yeah, Joey gave me the code. And the other person still won't admit it. It's crazy. It's like, I don't know. They've never read about the prisoner's dilemma. So I just wanted to give you, this is grad school. This is us talking. It's just me and you. Don't worry about YouTube or anybody else seeing this. I just wanted you to get the inside scoop, right? The skinny on all of this stuff. People who've been programming for, and you know, because you're a programmer now, right? You're already doing object orientation, so you're a Python programmer. The more experience you get with it, you're going to realize not easy. It's not hard to see this stuff. You can see it. You can definitely see it. And even if you're an old school programmer with some experience and you know how to change things around and you know how to rearrange things and make it look different, you're still going to get bagged. All right? You're still going to get bagged. Chucky and Joey are now in the mud, and they've got an academic integrity beef, and they've got to go tell a dean why they cheated. What's even worse in this particular class is having to go to a dean and tell someone why you cheated in grad school. Cheating in grad school. Ooh, that's a bad one. Okay? Frankly, back in the day, it would get you tossed. Right? It would get you tossed right out of school. But nowadays, they'll read you the riot act. You'll have to jump through some fire hoops. I hate when cheating incidents happen because then I have to give people an incomplete, give them an extra assignment, talk to a dean. If they fight it all the way to the top, then you have to go to a hearing and a kangaroo court. And then I just show the deans this analysis, and the deans will turn around and look at a student like they have 5 heads. So it's not a good thing. At the end of the day, first of all, I wanted you to see this kind of stuff because it's interesting. Second of all, don't cheat. It's not worth it. And it's funny, if you just say at the beginning of a course, we'll know if you cheat, it sounds arrogant. And it sounds like, yeah, you know what, they wouldn't know. He's just saying that so nobody cheats. No, I'm not just saying that. We know. We can do analysis. You can see, even if you're an old school person and you know how to cheat, you can make something look different, you're still going to get bagged by the software. The software has no heart. The software has no emotion. The software is going to take into account comments, variable name changes, rearranged functions, and just bag you. So all this said, I'm not accusing you of cheating, and I know you wouldn't cheat, and I want you to see this inside baseball stuff and be good with it. But if you get home late from drinking that night and you haven't handed in your code, just send me an email and say, I was out drinking. I need an extra day. Maybe I bag you a grade. So what? You get a B instead of an A. It's a lot better than getting an F and having to go tell a dean that you cheated in grad school, right? So I'm just throwing it out there. I want you to see this stuff. And I implore you, don't hand in something that's not your own work for Unit 5. Because we're going to know. We've been through this a bazillion times. And every time the TAs, myself, people in the MDS offices, every time it happens, we just put our heads down and shake our heads. And it's like, we got to go through it again. And we know. And every time somebody's going to deny it. And then we run through the analysis and it's 100%. And they're like, oh. It's really a bad deal. Okay? Okay, done. Other than that, you guys are really doing well. This is a really good cohort and really good things in the discussion. And I'm really looking forward to seeing the proposals after the weekend. I'll probably get to them on Monday and Tuesday. I promise I will get them graded up ASAP so you have the largest amount of time possible to work on your final project. I know it's summer. I know it's an individual project, so there used to be a design document, there used to be other components. Right now it's just a proposal, and then you work on the final project, the code with the rubric, and then a small demonstration. Demonstration, it doesn't have to be a half hour. I'm talking about 10 PowerPoint slides, maybe a 5-minute YouTube video that shows you using the code, okay? Nothing crazy on all that stuff. I put up the examples for the proposal. I'll put up some final project examples when that gets late, but like you've heard me say, I want you to be creative and try your own stuff first. I don't want you just looking at the worked examples and saying, okay, I will plug my stuff in here and do this and handing me the exact same thing. I know some people are going to do that. Some people are going to use the exact same format as the worked examples and then just plug in their information. I mean, at the end of the day, what am I going to do? I can't really bag you for that because it's what you want to do, and it's in a format that in the past I've liked enough to give out as an example. So it's almost like you can't go wrong. That said, think out of the box. Be creative. If you're just aping the current worked examples and putting in your stuff, you're not going to get 9 out of 10 points for it. I can tell you that much right now. All right? But you guys are doing great. I hope over this weekend to catch up on some grading. Myself and the TAs are putting together a plan to get the midterms done, so don't worry. We're going along on that, but most people in this course are doing great grade-wise, so I'm not concerned with that either. All right? All right. You have a fantastic weekend. Hopefully it's been a good summer. You're getting stuff done. Summer flies, doesn't it? We're almost done. We're almost done with Python. In the middle of August, you're going to be done with the course. You're Python programmers already, so congratulations on that. And we'll keep moving along, and we'll keep doing what we got to do. All right? All right. Then goodness gracious, I have already gone too long. What is that? 35 minutes? 35 minutes, but hopefully you learned a little bit something, and hopefully it was fun. And hopefully now you realize that don't cheat because we know. And it's not worth it. Just, dear professor, I was out drinking last night. Give me an extra day. I'll say yes. Okay? All right. You guys be good. I will talk to you later. Keep doing what you're doing. Have a great weekend. Take care. Bye-bye.